About 25 minutes, so I just want to review a little bit from last week because our lab today is dealing with a lot of these same concepts that we talked about at the end of last week, and then we will we'll get into it a little bit more Thursday. So if you remember from last Thursday, we started putting these ionic compounds together. And we looked at the charges of the ions, which sometimes you could tell from the periodic table, and sometimes you could not. And then we built these compounds based on balancing the charges, the positive and negative charges of the two different ions. So today we're going to keep doing that. We're going to add one more class of ions, kind of put this all together. And then that's really what you'll be doing in lab today also. You'll just be doing it experimentally. Yeah. There should be now. I put it in while you were doing the quiz. So just at some point before you get started, you can submit that. All right, so our last category of ions that we need to know about are called the polyatomic ions. Up to this point, all of the ions that we've dealt with are what we call monoatomic ions, meaning they're just made from one atom. So like an iron ion that's an iron 3+ is one atom. A chloride ion that's Cl-1, that's one atom. But there's also ions that are made of a bunch of atoms together. And those are called the polyatomic ions. You've probably heard of some of them because they have a lot of biological importance and just common in everyday life. But we're going to list the ones that you need to know. If you look in the book, where'd my book go? Here it is. If you look in the book, there's this big table of common polyatomic ions. You don't need to know all of them. There's a selection of them that is in the objectives that we're going to focus on and that you do need to know. So let's look at those now. And when I say you need to know these, you need to know 3 things about them: the name, the formula, and the charge. The problem with polyatomic ions is there's no fun way to figure out what their charge should be just based on where they are on the periodic table or something. You just have to know this ion has this formula and this charge. That's it. There's no real good way of doing that other than just remembering it. But I'm sure you're all up to it. You have to take like anatomy and stuff anyway, right? So you got to memorize like thousands of things. You might as well throw a couple more in there. So here's the ones you need to know for this class. Ammonium is an ion that has the formula NH4, and it's a +1 charge. So this is what I mean by name, formula, and charge. You need to know that ammonium ion, its formula is NH4, and its charge is +1. The next one is carbonate, whose formula is CO3, and the charge is -2. So these are ions. This is why they're called polyatomic. So this ion is actually made of 1 carbon atom and 3 oxygen atoms all bound together. So it stays together. It's not like a carbide ion and an oxide and 3 oxide ions or something. It's this thing that's all together as 1 ion, even though it's made of multiple atoms. All right, next we've got bicarbonate, which you've used in lab already, which is HCO3, sometimes called hydrogen carbonate. Hydroxide is OH or HO minus 1. Nitrate, which is NO3, and its charge is minus 1. Phosphate, which is PO4, and its charge is minus 3. The highest charge of all of these that we're going to learn. And finally, sulfate, which is SO4 minus 2. All right, so just 7, not too bad. But you need to know the name, the formula, and the charge, because what we want to be able to do is to use these to put compounds together in the same way that we did with all those other ions. So let's try that. It'll be a good review from last week anyway. So let's say we want to make the compound calcium hydroxide. Let's remember back to how we do that. What do we do first? Yeah, we're going to write down the symbols and figure out the charges. So we've got Ca for calcium. And hydroxide now is just one of these ones that we have to know from the list. So now we've got the list next to us. Eventually you won't have the list next to you, but you'll just know them. But we know that hydroxide is OH minus 1. And what's the charge on calcium ion? It's going to be plus 2. How do we know that? From the periodic table, yeah, it's in group 2A. So it has 2 valence electrons. So it's going to lose those 2 valence electrons and become a plus 2 ion. All right, so now we've got our 2 ions written down. How do we make a compound from those? Do we just stick them together, CaOH? No, what do we have to do? We need an extra hydroxide because we need as many plus as we have minus. So we need to put a second one of these here. And then when we write our formula, we have to express that there are 2 of them. So the way we do that, we can't do it exactly as we did before. We can't just put a 2 there. Why not? Yeah, that makes it look like there's just 2 hydrogens. So the better way to do that is to put parentheses around the polyatomic ion and then put the 2 outside the parentheses like that. If there's only one of them, we don't need the parentheses. Like NaOH, we don't put the parentheses around the OH. But when there's 2 or more, we use the parentheses to show that there's multiple of that entire polyatomic ion. All right, let's try another one. Give this one a try, aluminum phosphate. And if you get this, whoops, I didn't, sorry, there's no aluminum phosphate. I meant aluminum sulfate. And then if you get that one, try ammonium nitride. All right, you get some for these? Well, I'll give you another couple minutes. All right, what'd you get for aluminum sulfate? Yeah, so, okay, we can put them together. So aluminum would be +3. And sulfate is -2.
Yeah, so we need 2 more of that first.
Right, so we're going to end up with Al2, SO4, 3. Okay, that works. So we've got 3 of the -2s and 2 of the +3s. That's 6 plus, 6 minus. So now the charges balance out. Okay, what about ammonium nitride? What's ammonium? Yep, that's going to be from our list, NH4 plus. So nitride is N, and it's a -3 ion because it's in group 5A, which makes it need 3 more electrons to get to 8.
So you 2 more.
Yeah. So we're going to go with 3 ammoniums and 1 nitride. This shows one of the areas that I see a lot of mistakes in. Be careful with some of these polyatomic ions. The words sound pretty close to this, not to the monoatomic ions. So for example, nitride and nitrate, or sulfate and sulfide, which is just S2 minus. So make sure you're looking at those suffixes to see which ion we're talking about. If this were ammonium nitrate, what would the formula be? What would that one be?
But would be fine. So
Yeah, it would be one of each NH4 and NO3. So we'd have NH4 for ammonium and NO3 for nitrate. That's +1 and -1, so we don't have to adjust the ratio at all. We just have NH, whoops, we don't put the plus there. We have NH4, NO3. All right, and that's our ionic compounds. Okay, so let's put this all together. And I want to challenge you a little bit now that we have the list to not look at the list. That may be asking too much since we just put up the list like 10 minutes ago, but let's give it a try and see what happens. So I'm going to give you a few different ones from all the different types that we talked about last week and today. See if you can write the formulas, and then we'll see how it goes. So we got copper 2 sulfate. Titanium 4 oxide. Zinc. Now, zinc is a little tricky because technically it is not variable charge, but because it's in the group with the other ones, I'm going to put its charge here anyway to help you out. One really good way to check yourself and how you're doing is try these and actually write down what you think the formulas are without trying to look anything up back in your notes. Then take a look back and see, okay, did I get this set up right or not? So trying it first and really writing it down, even if it might be wrong, is a good way to check yourself. All right, we only got about 5 minutes left. So how did these go? You got them? All right, I'm going to put down the names, and then if you have questions, let's go through the ones that you didn't quite get. Copper 2 sulfate is going to be CuSO4. Titanium 4 oxide is TiO2. Strontium nitrate is SrNO3 Zinc 2 sulfide is going to be ZnS. And then ammonium phosphate is NH4 and then PO4. How'd those go? You got them? Questions? No? Okay. This is going to take a little bit of practice. And then the next step is going the other way. So if I give you a formula, can you write down the name? Let's try it. Try these two. See if you, without me even telling you how to do it, see if you can write down the correct name. And then we'll talk about it for each of these. Take about 2 minutes. All right, anybody got some names? Want to give it a try? What do you think for the first one?
Cobalt nitrate.
For the first one? Close. Try one. Sodium nitrate. Yeah, the first one's going to be sodium nitrate. We got sodium Na and nitrate NO3, and that makes sodium nitrate. Okay, what about the next one? Close. Close. You combine those two. It's this. Okay, so let's write it down. So cobalt sulfate has one thing missing. What's missing? Yeah, we need the 2 because that's in the middle. In that middle section, remember, they have variable charges. So we don't know what kind of cobalt this is. We don't know if it's cobalt 2+ or 3+ or whatever. So we have to specify that in the name. So whenever you encounter those middle elements called the transition elements, you need to specify which charge you're dealing with here. In this case, we want the one that's 2+. Good question. How do you know it was the 2? So we knew it was the 2 because we know that sulfate is SO4 2-. And we know from the formula that there's only one cobalt. But the only way that you could have only one cobalt is if that balances out, is if it had 2+. That's the only way you could get that to balance. We'll practice this more also on Thursday and in lab today too. But that's it for right now. So I'll see you in 15 minutes and we'll talk about lab. There should be a place to submit your pre-lab now on Blackboard. So if you could please do that. And then we'll discuss the experiment when we get started.